Welcome back to Project Pulse. In the previous lessons, we focused on the operating side of the model, all the different revenue streams and the operating expenditures that drive the cash flow waterfall. In this lesson, we move one step up the capital stack and look at CapEx, what it actually costs to build this battery project. If you're new to this Deal Lab series, I recommend starting with part 1, where you can download the model start file for free and build the model alongside me. Link is in the video description below. In the information memorandum, you find the full CapEx picture we are going to implement. And in this lesson, we will focus on 4 building blocks. The first block covers our direct EPC unit costs. Things like our actual batteries, the power conversion system, transformers, the energy management system, and interconnection costs. The second block covers development costs and contingencies. Then we'll move on to the acquisition premium, which is a turnkey acquisition premium on total project costs. And the last block we are going to cover in this lesson are our transaction costs, which are legal, technical, and insurance fees at financial close. You can also see assumptions on tax depreciation, augmentation costs, and the major maintenance reserve account. We'll keep those for the upcoming lessons once the basic capital expenditures are in place. Something I want to emphasize here is that a key assumption for Project Pulse is that this is a turnkey acquisition at COD. WaltCap Partners acquires a fully built operational asset. That means that we do not model a construction period or construction financing here. All CapEx are treated as incurred at financial close with the asset ready at COD. If you would like to go deeper into multi-year construction schedules and construction debt, that's something we cover in our other advanced project finance modeling courses. Now let's move back to the checkpoint file from our previous lesson. All of these CapEx items are reflected here in the inputs time independent sheet. We capture the costs and units for each EPC component, the percentages for development and contingency, the acquisition premium as a percentage of all costs, and the lump sum transaction costs. Now let's move on to the operations sheet and translate those inputs into the model logic. In the previous lesson, we have modeled our operational expenditures, and now we'll move on to the capital expenditures. And we will start with our direct EPC costs in cell K315, where we will start with picking up a flag that we haven't used before. So scroll all the way up. And for our CapEx, we want to make sure that we pick up our financial close flag, because for this structure we assume an acquisition at COD, which means that debt and equity will close concurrently and that all CapEx are paid on the same day at financial close. So hit F4 2 times to only anchor it to our row, and let's multiply this with, scroll back down, our unit cost, which is $160 per kilowatt hour DC. Hit F4 1, 2, 3 times. And you can see that we have this unit only 2 times for our battery packs, which includes the cells, racks, containers, and the battery management system, as well as the balance of the system and the EPC installation itself. So those 2 rows have this same unit. Now let's pause for a second. Our unit here is given in USD per kilowatt hour. If we want our output to be in thousands of US dollars, then we would have to multiply this with megawatt hours, because 1 megawatt hour equals 1000 kilowatt hours. So if we can just simply find our installed energy capacity in megawatt hours DC, then we should be good. And we should return a 1000 USD value. So let's multiply this with, let's find our megawatt hour DC value up here in the power section. And that will be the DC energy at beginning of life in cell G66, which is given in megawatt hours on a direct current basis. Make sure that you pick up the initial value at beginning of life, because this is the basis for what we'll have to pay for in our CapEx section. Hit F4 once to fully anchor this one and hit enter. And you can see in case 15, which is just a 1 hour battery, we will pay $42.4 million for our batteries, which include cells, racks, containers, and the battery management system. And the balance of the plant, hit Control D, will cost $6.6 million. So let's drag this one over, Control R. Although it will only be picked up at financial close, it's still best practice to drag it all over. And then we can move on to our next 4 items, which is our power conversion system or inverters, something we have learned in the previous lessons, as well as the transformer, which we also learned about in one of the previous lessons, the energy management system, and interconnection costs. And this one is going to be given in a unit in US dollar per kilowatt AC. So that's the actual capacity at the point of interconnection on an alternating current basis. And this makes sense because things like the interconnection, transformers, and power conversion system, as well as the energy management system, are all sized based on a point of interconnection, and they are not sized based on the actual installed batteries. So it makes sense to have a different unit for these inputs here. And this is going to equal to, let's pick up our financial close flag again in K11, hit F4 2 times. Let's multiply this with the actual input from our input time independent sheet. $120 per kilowatt AC. Hit F4 3 times. And now let's do the same again. We are given an input in USD per kilowatt. If you want thousands US dollars, let's find megawatt AC. Scroll back up to our power section. And the gross power capacity at the point of interconnection is going to be 200 megawatt AC. So let's pick up G47, hit F4 once, and hit enter. You can see that our power conversion system is going to cost $24 million versus the battery packs that cost 42.4. Copy this and paste special the formula only, Alt HVS F. And let's drag all of this over, Control R. Now something to keep in mind here is that in the case study, what changes is the duration of our batteries throughout the different cases. So in case 15 right now, we have a 1 hour duration, which is given right here. You can see that in case 15, we're picking up a 1 hour duration. But if we switch to a different case, such as our resource adequacy plus arbitrage case in case 5, you will notice that our costs for the batteries will change, but our costs for things like the power conversion system should stay the same. And the reason being is the underlying unit right here. Because if you want 4 times the duration, we will also have to install 4 times the containers, racks, and cells. However, the power conversion system and the point of interconnection will be sized still at 200 megawatt AC, which means we do not have to fourfold the size of our power conversion system, which is the reason why these CapEx here stay flat. Then let's take the sum of all of these direct EPC costs and let's drag this one over, Control R. And you can see that our direct EPC cost for case 5 is going to be 243.7 million USD. And now that we know our direct EPC costs, we can move on to our development costs and contingency. And this is going to be a simple percentage of the direct EPC. So we take our unit cost in percent, hit F4 3 times, and let's multiply this with our actual total direct EPC costs in row 321. Hit F4 2 times, enter. And here we do not have to link to our financial close flag because we have already done so for our direct EPC costs, which is why we only pick up a value here if we actually have total direct EPC costs. Let's copy this formula, paste it special here, Alt HVSF, so we don't mess up our formatting. And let's drag this one over to the right, Control R. And what this assumes is that our actual developer will roughly have to pay $7.3 million to develop the project. And we will also have a $12.1 million contingency in case of cost overruns of the actual total direct EPC costs. Then we can take the sum of those two items, drag it over, Control R. And this will allow us to model our turnkey acquisition premium that an investor coming in at COD would likely be willing to pay. The case study assumes that it's going to be 8%. In the real investment world, this input here would likely change depending on the asset structuring of each specific case. But this is just a case study, so we assume 8% flat for all cases. And this is going to be equal to our 8% of all costs. Hit F4 1, 2, 3 times, and let's multiply this with the sum of our total direct EPC costs, comma, our total development and contingency. Close parentheses, hit enter, and let's drag this one over, Control R. And that would translate into an acquisition premium of roughly $21 million US, whilst the developer is expected to pay roughly $7.3 million to develop the asset. So at COD, it's expected to not only get reimbursed for these development costs, but also to make a profit threefold of the initial investment. Then the last thing we will pick up are diverse transaction costs, such as legal, technical, and insurance due diligence, and advisory services. So this is going to be $1.8 million US. So we just pick up the 1.8 million, hit F4 1, 2, 3 times. Let's also multiply this with our financial close flag further up here. Hit F4 1, 2 times. And since the input was given in US dollars, what we will do is divide this by 1,000. So divide by 1,000, hit enter, drag this one over, Control R. And these are basically all the CapEx inputs we wanted to model in this lesson. What will come in one of our later lessons is CapEx related to our financing fees, which is usually an upfront fee on our senior debt and an upfront fee on our debt service reserve letter of credit. But for now, we have not yet modeled our financing section, but that we don't forget this, let's actually highlight this in yellow to make sure we are not forgetting these calculations later on in the case study. And right here, we can already take the sum of these two rows here, drag them over, Control R. And then here we have a simple summary of all our CapEx, and this summary will be directly linking into our integrated financial statements. So this will come from 340, which means that we also have to summarize all of our different CapEx that we have modeled right here so that it's actually picked up in our integrated financial statements. And this is going to be a simple linkage. So let's start with our first 6 CapEx items. Drag this down up to the interconnection costs, hit Control D. Then for the owner's costs, we will link this to row 324. Hit Control D one time. Then we also have our turnkey acquisition premium right here. And our transaction costs in row 332. Which allows us to take the sum of this. And let's select all of these rows here and drag them over, Control R. And we can see that our total CapEx, excluding our financing fees, are going to be 286 million in case 5. Let's see what we would actually pay for 1 hour battery, which should be significantly cheaper. And it is. In case 15, we would only pay 114.5 million USD. because now we only would need a quarter of the actual battery cells and so forth, which makes the project overall much more affordable. Then in the last section here, we can link to our total CapEx and our financing fees, which are going to equal to our total financing fees, which we haven't modeled yet, but let's set up the linkage anyway. And then we can take the sum of those two guys, drag it over, Control R. And that completes our CapEx section for this lesson. In the next lesson, we will pull in our financing fees. And let's see how our integrated financial statement looks. And we see that we now have total uses of funds. However, what's still missing are our sources of funds, which is going to be our equity and term loan that are actually going to be used to finance all of these sources of funds. And that is the reason why we have net cash flow after funding of $114.5 million. This value should always be 0. So in the upcoming lessons, we will first have to model equity and term loan to ensure that our net cash flow after funding is actually 0 in each period. And in the next lesson, we will stay in the CapEx world and cover augmentation CapEx and the major maintenance reserve account. And then after that, we will move on to how the project is actually financed with equity and debt. All right, guys, I will see you in the next lesson. See you there.